Let's look at the definition of perimeter. Perimeter means the distance around it. So if I give you a shape, it doesn't really matter what the shape is. Let's start with the triangle. There's a triangle. And I said, this distance is 5 feet. This is 6 feet, and this is 8 feet. What's the perimeter for that shape? If you were to get a fence to put on the outside of this shape, on the edge of that, how many feet of fencing do you need?
20.
How many? Why 20?
5 + 6, 8.
Let's see, what's 5 plus 6? 11 plus 8? 19. So you have an extra foot left there. But we need 19 feet of fencing. If the shape was, we have a rectangular shape. And this is 10 and this is 5. What's the perimeter for this one? It's 10 plus 5 plus 10 plus 5, which is 30 feet. Now, if you look at that number, it looks like we have 2 10s, right? And we have 2 5s. The 10 is actually, isn't that the length of that shape? And the 5, isn't that the width of it? So really, the perimeter of a rectangular shape is twice the length plus twice the width. 2 times the length plus 2 times the width. So if you don't want to add all the sides, that's one way to get it. If you recall last class, I don't know if I gave you the handout, right? Yep. On the handout I gave you, if you look at that, and you can use them when you do your homework, there's the perimeter. Oh, there's the rectangular shape. P is the perimeter. We use A and B here instead of L and W. But twice A plus twice W. See it? I mean twice B. Twice A plus twice B. That's the perimeter. What's under that? That's the area. Don't worry, that's section 3. Section 2 does not deal with area, only perimeter. Section 3 is the area. We'll come back to these. So the perimeter is twice A plus twice B. If the shape is a parallelogram, so let's take a parallelogram and see what the perimeter of that shape is. Here's a parallelogram. 7, 7, 11, 11. What's the perimeter of that? Again, if you have to put a fence on the outside, what do you need? Isn't that 11 plus 7 plus 11 plus 7? Which is 36. Or the perimeter twice this side, we'll call that A and this is B. Twice A plus twice B. Twice of this side plus twice of that side. If the shape was a trapezoid, now a trapezoid, only 2 sides are parallel. This is A, B, C, and D. They are not equal, so I can't use A and A here or B and D here. The perimeter of that is, what do you do? you add all the sides. Again, think of the perimeter as a fence. A fence you're going to put around that. Notice right here, trapezoid, the perimeter is A plus B plus C plus D. What happens if you have a funky shape? We got this shape. I'm just making one up. Here we go. I'm going to go have fun with it. We got this shape. 10, 5, 4, 2, 3, 6, 9. What's the perimeter of that shape? We add all the sides. There's no equation for that because we have just a crazy shape. You add all the sides. 19, 25, 30, 34, 39. Now, what about if you have a circle? And we said the radius is 9. Thanksgiving's coming up. You're going to make some pie. You have this massive pan there. You're going to make an apple pie. If you were to take a measuring tape, go on the outside. If this is 9 inches, the radius. That's a big pan, by the way. And 9 inches. This is the radius of it. So it's almost the size of a tire. This is not a pan. This is almost, what is that, tray? A big tray, you know? If that's 9 inches, what's the distance around?
18.
Well, let's look and see. When you have a circle, that's called a circle. The perimeter of the circle, we have an equation for that. 2 pi r. 2 pi r. So the perimeter, it's 2 times pi times r. Now, for people never seen pi before, the book will tell you to use, they'll tell you which one to use. Sometimes we use pi equals 3.14. If you look on your if you have a calculator and you look at it, you push that pi button, there's more than 3 digits. Actually, pi has infinite digits. It never stops. But if I look at the first few digits of that, where is pi? Let me find it on this one. Where'd you go? I hate whoever made this color blue. Oh, here we go, pi. 3.141592654. A lot of times we'll say use 3.14. Or they might say use 22 over 7. 22 over 7 is not really accurate. It's an approximation. Watch this number. If I put 22 over 7, do I get close to it? Can you see that number? 3.1428. This is 1415 or 16. So close. If I'm using 2 digits, I'm fine there. So a lot of times they say use 22 over 7. The problem will tell us what to use. So if they don't tell me what to use, I'll just use the pi key on my calculator there. And I go 2 times, and I'll hit in the pi key, and what's r equal to? 9. So let me go to my calculator. Here we go. If you don't have one, use 3.14. 2 times pi times 9. 2 times pi times 9. Hit equal. And it says what? 56.55 if I use 2 digits. So if you were to take a measuring tape, go on the outside of that tray there, because that's a big tray, that distance will measure 56.55 inches. Now, if you are making pie this weekend, when it's a 9-inch pie, that's diameter end to end. Think of the diameter as like a tape where you stick one end to the floor and you roll it, and as you roll it, that tape sticks to the floor. If you go one turn, how far did it stick? Like I have a tape here. You probably can't see it. It's clear. If I mark a beginning of the tape, can you see that beginning here? And if I stick that beginning right here to the tape, to my paper, and I go till it reaches the other, where's the other end? Right here. That's actually what the circumference is for one turn. Can you see it from end to end? That's what that means. So if you turn it, now if this was bigger, do you think that distance will be bigger? If I take this one and turn it in one turn, would that give me the same distance as that Scotch tape? There's no way. Let me mark this one. Watch one turn. Look at that distance. That's way bigger than the Scotch tape there. Tape out. Now, tires on the car come in inches. I'm not really expert on them, but let's say what? Let's say a 28-inch tire. And I don't know, 28-inch, I'm assuming that's where's let's say that's end to end. Is that a big tire? I don't know what the size. We'll compare it to 26-inch tire. A little bit smaller. When a tire makes one turn, how far did it go? Well, let's look at 26. At 26, that's the diameter, right? Diameter is end to end, that's 26 inches. Then what is the radius of that? Radius half that number. 26 divided by 2, which is 13. So if the tire makes one turn, the circumference, we use C because circumference is the distance around. Is equal to what? 2 pi r, which is in this case 2 times pi. We'll find out what that number times the 13. I'll go to my calculator. 2 times pi times 13, which is you traveled 81.7 inches roughly. Now, if you put bigger tires on your car, diameter here is equal to what? 28 inches. What's the radius? 14 inches. What's the circumference? If you make one turn, how far did you travel? 2 pi times 14. It might not seem a lot adding that extra inch. 2 times pi times 14. You travel actually 87 point, actually 88 if you cut it to 1 decimal place. 88 inches versus 82 almost. You have 6 extra inches every time you make a turn. That could be a change in your speed in your car. You know, where your speedometer said if you put these big tires, let's say your car was fine. 65 miles per hour here was 65 miles per hour. You go buy tires and you buy the bigger ones. If you have these tires put on your car, when it says you're going 65, you're actually not going 65. You're probably going 72 miles per hour because of bigger tires. So your speedometer is saying, oh, you're going 65. The speedometer is counting how many turns the tire is making. But the distance each time you turn is actually a lot bigger than before. So the distance you're covering is a lot more in that time there. So you going speeding. I know that from experience. I got pulled over going 65. At that time, the speed limit was 55. And I argued with the cop. He goes, no, you're going 70. I said, I can't be. I was going 65 top, maybe 63. And I argued. I got a ticket. I argued with the guy. Then I got on the highway. I had my wife in her car next to me. I said, how fast am I going? She goes, 72. I go, no, I'm going 64. No, 72. Then it hit me. I put new tires on my car, and the guy had a special deal going on. I'll give you cheaper ones if you buy these bigger ones. I don't know anything about tires. Sure, put the bigger ones on. You know, good tires, cheaper, I'll take them. But that's what it does. That's where the circumference comes in. The distance around. Sometimes we give you crazy shape and say, what's the distance? For example, you go to the track, you decide, you know, I'm going to go work out. Everyone telling me I should start working out, I'm going to go. And you go to the college here, the track, and we'll use Springfield College track here. It looks like this. They have a football field on the inside. You've probably seen it. Let's say it's 100 yard here. By, I don't know, I'll use 50 yard here. And at the end of that, they have what? They have half a circle on this end and half a circle on that end. And when you walk, you're not walking on the inside. When you decide to go on the track and walk, you're going to walk this way. That's where you're going to walk. So if you only do one lap, how far did you travel? Can't be two. Two if you just went this far and back. It's 100 here, 100 there. What about that little piece and that little piece? So you got the 100 yard plus the 100 yard here. You did that. But what about that piece and this piece? Well, you didn't go straight down. If you walk straight down, it's 50, but you went like this. Yeah, if you went down here, 90 degrees, down here, 90 degrees, you're right. It'll be 50, 50, 150, 150. But this time you went on the outside. So we know it's 200 yard, that's where you walked, which is this 100 plus that 100 plus what? You have half of this piece, which is that piece, right? And half of this piece, which is that piece. And when you put them together, what do you notice? What do you have? A circle. The outside of the circle, that's the distance that you walked. That's the circumference. Now, what is the radius of the circle? Try again. 25. Very good. Because the 50 is that distance from this end to that end. That's the 50. See that 50? So the radius for this circle is actually 50 divided by 2, half that number, which is 25. So what did you walk? It's the 200 yard plus the circumference, which is what? 2 times pi times r, which is 25. That number here on the outside is 157 roughly, and this is 200. When you add them, how far one lab is? 357 yards. So if you walk 4 laps, you multiply it by 4. If you do 10 laps, you multiply it by 10. If you do 7 laps, times 7. $357 yards, one lap. Or you might have a window in your home. And the window looks like this. 6 feet here by 3 feet, and you have half a circle on top of it. One of those windows some of you might have, right? So if you want to buy a trim to go on the outside of that, a trim, it's going to go like this. How big is that trim? Well, this will be 6, this will be 3, right? So the outside, that's called the perimeter for this, is going to be the 6, that's this side, plus the 3, that's this piece, plus the 6, that's that piece. And what about that one? What's that piece looks like? Half a circle. Half of a circle. So if I know what half the circle is, I know what that perimeter is. 6 and 3 and 6, is that 15? 1/2 of means multiply. A circle is what? The circumference. And the circumference of a circle is what? 2 times pi times r. What's r here? What's the radius of that circle? Half what? Half the 3, sure, 1.5. Half of the 3. What's half times 2? 1. Times pi times 1.5. So what do we have? That's a 4.7 roughly feet, that half the circle. This one here, when you multiply it, it's 4.7 plus the 15, that's 19.7. We can create different shapes, different looks, ask you for this, ask you for that, but the whole idea is, okay, what do you have there? What is the shape that you got there? And we have to know the equations. You don't have to memorize them because that cheat sheet is handy. Right there. 2 pi r is the perimeter for the circle.